Welcome to the Aerospace Ambition podcast. I'm Marius, your host, and an engineer with a keen interest in the intersection of sustainable aviation and AI. In today's episode, we're going to explore Single European Sky ATM research, or short, SESAR. Please welcome Alain Siebert, Chief Technology and Strategy Officer for the SESAR 3 Joint Undertaking at the European Commission Agency. With a focus on modernizing European airspace, Alain sets the strategic direction for the EU's ambition to create the most efficient and environmentally friendly skies. His expertise guides innovation to meet policy goals, coordinating with the EASA and national bodies. Alain's career advanced from Air France to a strategic role at the SAS Group, reinforced by a master's degree in technology and innovation from Ecole Polytechnique. Alain, welcome on the show.
Hi, Marius. Glad to be here.
Thanks for being here. And this is the perfect opportunity for our audience to properly understand SESAR. We had some guests before where we alluded to some projects, but I think this is a perfect way to set the stage. So what is SESAR and what is its history?
Well, essentially, SESAR is a EU project that is driven from policymakers and has been driven for close to 20 years. Its birthplace is actually a little bit sad in the sense that it originated in the time of the war in Yugoslavia. And at that time, there was a realization that war would have a very dramatic impact on the capacity and efficiency of airspace to be managed in Europe. There was a lot of delays. All of a sudden, bottlenecks appeared a little bit everywhere. And the politicians said that we cannot continue like this. We need to do something about it. And already 20 years ago, there was an understanding that technology should be part of the solution. And that's where the idea of having a technological pillar for this political project called SESAR originated. So this is really, I would say, the political birth of a policy-driven project that has since evolved over the past 15 years, 20 years into one where there is a very deep understanding that technology probably holds the biggest promise to transform the way we fly.
Great. And I'm going to slip in a question here that I wanted to ask later, but since you explained that the birth, was given through, the circumstance of a war, I'm asking myself, currently we also have some military crisis around the world. How is this affecting air traffic management?
Well, it has very direct implications for the whole aviation value chain in Europe. If I just focus then on the ATM component, there is a significant portion of the airspace in Europe that is currently not in use any longer. We are, of course, talking about traffic over Ukraine, but also Belarus and at the borders, as you get closer to Ukraine because of military activity. And this creates a complete new flow of traffic in Europe and the way Europe connects, in particular, at our eastern border. And I mean, you can only imagine the implication on Europe to Asia Pacific region flows, but also the Middle East. And it creates bottlenecks or huge capacity challenges in areas around that zone, but also complexities for those that are directly impacted with very severe drops in traffic. And we don't have a system that today is really scalable easily to fluctuations and variability in demand because it's a very labor intensive system. So this poses huge operational challenges to maintain an orderly flow of traffic and also maintain a high performance of the EU aviation system.
So military conflicts pose a huge challenge for ATM, but then also a more positive aspect is a predicted growth in air travel.
Yep.
Since you mentioned some of the limitations, you mentioned staff, basically, the human limitations in ATM. What are the most critical factors we need to look at in order for ATM to scale accordingly?
If you're taking a standpoint today, which is you have essentially an organization of air traffic management that is based on an ability of a controller and a supporting controller called a planner to manage, let's say, a maximum number of aircraft on his or her screen at any given point to maintain safety. To do that, you allocate the attention of a controller to a fraction of the airspace, and the more traffic grows, the more you need to reduce gradually the size of these pieces of airspace or sectors they are looking at, just to handle the complexity for the human brain of processing too much information and maintaining safety. We have essentially reached already in 2019, pre-COVID, the capacity limits in Europe. And what we have done in the past when we needed to grow, which was to just recruit more controller and segment the airspace into ever smaller pieces, is just becoming increasingly operationally difficult to implement. And we need to look at a new range of solutions moving forward and embrace digitalization to do so.
Right. So technology will play a key role in all of this. And in order for technology or applications to be applicable in such a safety critical environment, we have to bring up the readiness level of such technologies. And for that, SESAR deployed a pipeline, the SESAR pipeline. Could you maybe elaborate the process behind that?
Yeah, so the whole idea of the SESAR project, and let's say for an EU body like ours to be engaged on this, is to somehow have a new a body that is purely technology focused. So I think that is already an important point, because our mission is really to build confidence close to regulators and policymakers on the next generation of technologies to help evolve the policies and regulations so that these technologies can be adopted in the best possible way and at the right pace. So our program is designed to stimulate anything from bright ideas, and here I'm talking about exploration and science, or very low TRL activities, all the way to actually supporting early movers that would like to change infrastructure systems and implement and test in real operational environments with very high TRL levels and essentially have the first implementations. This is a relatively new development since our latest program called SESAR 3. Before that, we were mainly focused, I would say, in the TRL 0 to TRL 6 range, but we have learned that there is a kind of valley of death after TRL 6, and that continued EU support is necessary to help overcome that. If we want to actually change things, we need to bring things out of the lab and bring them into real operational environments. And this is why we also have what we call digital sky demonstrators, which is about demonstrating in real operational environments that it works and build a more solid basis of evidence.
One of the biggest challenges, I suppose, in creating this digital European sky is the fact, especially in Europe, that you have so many countries that are involved. So I'm wondering, what is the factor that politics play in uniting all of these countries into a single European sky?
I would say the fact that we have multiple countries working together towards a united vision of the sky is I would say one of the reasons for SESAR to be central in all of these conversations. And if you look at it from a positive angle, it is an opportunity for us to have a coordinated approach across states for a continent like Europe. And we are in a quite unique situation when I look at other regions of the world where this level of coordination, working out a vision together, agreeing on plans together, agreeing on actions together is an envy to many. It also adds a lot of dimensions and viewpoints and cultures on how specific problems can be solved. a vision of, a Scandinavian region can be very complementary to a vision in the Mediterranean area at times, and that diversity helps us in problem solve. The challenges then, of course, is when it comes to adopting regulations, in making sure that we move all in the same direction, that it can give the impression of being slower than if it would be a single state with fewer actors involved. But at the end, what I care about is not just an impression of speed, but what is our real speed of transformation. And despite the complexities we have in Europe, I would argue that we are doing a very good job in Europe compared to other regions of the world, because we have agreed to collaborate under one program at European level.
Okay, so this is the political angle at things. Now, zooming out and including the whole ATM industry, where do you see areas where we still lack consensus?
It's an interesting question. I would say you can look at it also there from two angles. Where would we lack consensus within Europe versus also with the rest of the globe? Because the initiatives that we are working on, we cannot think of it purely in isolation, because aviation is a global business. So I would start with within Europe. I think we are actually doing a pretty good job. I wouldn't see any, I would say, blocking points right now in terms of consensus, but we do have very interesting and tough conversations that right now gravitate primarily around one: if we want to establish Europe as the most efficient and environmentally friendly sky to fly in the world, what would be the implications of doing so? And if environment really now has to be at the heart of optimization of air traffic flows, it is essentially challenging the fundamental design of ATM and forces us to rethink quite a number of things. And we have numerous debates about this, because our industry has so far been optimizing primarily on safety, which will have to continue. But if you would throw in the environmental dimension there and really make sure that this is now systematically, embedded in the way services are delivered, in the way systems are designed, it is somehow a paradigm shift, and we have debates about this. Another big debate we have in Europe is about the speed at which we should then adapt to implement this vision. So we have a lot of conversation about what should we then really focus on, and what time horizons can we give ourselves, with a feeling that we need to act very rapidly on that front because of the climate emergency. That is a bit the picture within Europe. We also have, I would say, these conversations at global level. And what sometimes is difficult, I was recently in the Bay Area at a NASA workshop with a number of global players. When we present this vision and our ideas and how we are going to put all of this in motion, we are the only ones that really are advocating for a kind of turnaround from an environmental perspective at present. And that is due to political sensitivities. I mean, the environmental dimension is just such a driving force in Europe right now, and that is not say number one topic that comes out when discussing with other regions in the world that may have more focus on, purely speaking, capacity, for example, or integration of very specific vehicles. So if we want to move at the pace we want to move, and with the changes we want to push forward with, this is going to be an area where we need to also help shape a global consensus. And this is still a debate at global level, essentially the weight of environment as a cause for change in aviation, when other regions of the world just have the pressure on other drivers.
Such a complex topic, and you've described the questions that there are, where are we lacking consensus? But what is your take on those questions? Or just to start with the obvious one, like, what is the speed that we need? How urgent would you describe this? What is your answer to the question?
My answer to the question personally and in my function is that we need to move extremely rapidly on this. Moving extremely rapidly in a sector that is used to innovation cycles from idea to having something implemented of close to 30 years would, if we are reasonable, would force us to drastically shorten those innovation cycles. And I believe one of the big challenge for us is going to be over the next 5 to 7 years to develop very complex new capabilities and digital systems. And I hope that by focusing on the right technologies, we will be able to somehow make the implementation easier thereafter, and all in all, reduce the innovation lifecycle to 15 to 20 years, so that around 2040, we have established Europe as the most efficient and environmentally friendly sky to fly in the world, where by default, every flight will be optimized systematically in very precise ways, not just when there is extra capacity or time from controllers to do so, but by default. So this was on the speed dimension where I am pushing, and I am not the only one, to find and look at all ways we can shorten this innovation cycle in our sector. And we are looking at a number of levels to do so, but that would take me a bit of time to explain that.
Please, it's the perfect moment. If you could just, you can't say that and expect me not to ask a follow-up question.
So some of the ideas we are looking at is how can the economic regulatory framework work more hand in hand with the technologies that we are maturing? How can also the technical regulatory framework allow for an early adoption of those new technologies? And that requires a kind of mindset from regulators and policymakers that have their mind often and rightly so on what would be at a certain point in time the capabilities that everyone in Europe should have. To complement that with how can we make sure that those that want to move fast can do so, and to have solutions for both dimensions. What would be the slowest acceptable pace, and what can we do to allow the fastest possible pace for those that want to go fast? Because I think we need to support as much as possible those that want to move fast, because this is going to create a momentum. Another dimension we are looking at and into very much is what do we need to do to have, where necessary, the right focus on the availability of standards to enable a harmonized implementation of certain capabilities. Then we are looking at how can we innovate in the way we develop technologies to have shorter time to market, and move from traditionally in SESAR, we need 10 years from an idea to a solution at TRL6 to something that is closer to 5 years, whilst at the same time we are tackling much more complex and digital systems. The list is long, but we are looking at every one of the ideas, and there is no, I would say, stone that is left unturned.
I think there is another interesting aspect that our previous guest threw in the conversation. It was Chris Deseur from Thales.
Mm-hmm.
And the question that he passed on to you revolves around a distinction between you have these expensive, large-scale projects, but within them you also have smaller critical pieces. And his question concretely is, how can we accelerate the introduction of parts of the novel technologies coming out of SESAR into operation to deploy it at scale? Because he also agrees that we need to act fast. So in other words, can we modularize it and, take smaller pieces out and implement them more quickly?
Yes, I have a lot of sympathy for that. And I think you can do that in multiple ways. One is to, of course, have, I would say, projects that enable quick wins to be developed, fast-tracked, implemented. We have done so, and we will continue to do so, and I hope we will do more of this. I would argue that what is equally important is that we now fundamentally change the way the systems inside ATM have been built in a monolithic way, all integrated, replicated at every air traffic control center in Europe with, localized data processing, localized sensor connectivity, directly coupled to the human machine interface modules. We now need to have we need to equip our system with a modern IT system architecture where we essentially enable cloud-based computing, where we have a service-oriented approach that would be allowing a much more open way for our systems tomorrow to enable, I would say, modular improvements, but they will be, much faster and much deeper than anything we have been able to do. This transformation is going to take 10 years, but that is an area where I'm pushing very hard.
Let's look at the past for a second, and maybe you can share some of the key achievements within SESAR that have already come out of research, but also that have made it into operations. What are the first things that come to your mind?
I mean, the first thing that come to my mind is actually things that are in implementations throughout Europe. If I can only mention the way that, nowadays, if you fly and you're a pilot or a flight planner, you can plan based in a free route environment. So you essentially have lesser predefined virtual routes in the sky that you need to follow. And we are removing some of those artificial constraints where possible. So that is something that is in implementation throughout Europe. We have pushed a number of airport improvements at the key airports around Europe. Last week, there has been a confirmation that all aircrafts will have to be equipped with the ability now to downlink trajectory information that is on board the system, so that this can be shared throughout the network and there is a common reference for all trajectories. There is a lot happening behind the scene that is actually now part of not just voluntary deployments, but I would say this is something everyone is implementing. This all came out of the first SESAR program. On the voluntary side, we have the implementation of remote tower operations. That is a very good example of, I would say, just accepting that a controller doesn't need to be physically everywhere with his eyes looking out of a tower, but that he could be placed somewhere else and use digital information, camera, sensor information, and handle a tower operation remotely. And that has had a huge success, and we have this implemented in Sweden, in Norway, where from one remote tower center they are planning to operate 20 airports remotely, for example. This is a great example of results that just happen to be implemented on a voluntary basis at present. The list is long, but these are things that are concretely in implementation now. We are actually focusing on the next wave of deployments in Europe at present in the context of an update of the European ATM master plan. And there is going to be a lot of cool topics that are going to be rolled out in the period 25 to 35. So we are looking at the next decade. And that ranges from, having much higher air-ground connectivity, having the introduction of automation support tools for controllers, having a completely new architecture that is cloud-based and service-oriented for the core architecture in each center, enabling drone use with the implementation of U-Space and the first uptake of innovative air mobilities and EV tolls, further optimization on the environmental front with what we call trajectory-based operations, so better planning, execution of trajectories, airport enhancements. The list is relatively long and comprehensive and impacting really every phase of the flight.
I'm glad you mentioned the remote towers because that's a topic I find very interesting, especially because it, in light of the full digitization of the operations, it offers the potential to include more and more automation modules, let's say. And in those remote towers, what are examples of applications of AI or machine learning that are interesting for you?
I mean, in the case of remote towers, I would have to look more in detail about specific AI applications. But on AI, which is a big focus of the program, we have, for example, made a number of advancements in the area of speech to text, and you can imagine applications for that in a remote tower. Would it only be for keeping track of the exchanges that have been taking place between the controller and the pilot, all the way then to applications of AI more for services that enable a better planning of future traffic loads. So everything that is not too much in, I would say, the tactical phase of the flight, but more the strategic phase of the flight. And remote towers arguably are still primarily a tactical improvement area. So I would say AI is a focus, but in the case of remote towers specifically, I would have to check what the applications of it have been. It's less evident for remote towers than on other topics, at least at the start.
What are other topics that come to mind? What are you thinking about?
Well, I'm thinking, for example, about optimization for centers of future traffic loads. So I think I have mentioned a couple of times that one of the key complexities that we are trying to solve through digitalization is the ability of the air traffic management to scale up and down with demand. And that demand is extremely variable. Between summer and winter, we have very different demands. Between day and night, we have very different demands. Between a weekday and a weekend, we have very different demand, just to mention a few examples. And yet the whole system is built in order to be able to safely accommodate peaks. So everything that is not peak is suboptimal. And that's where AI applications that we have been looking at are really good at helping us better predict based on historic patterns, actual traffic loads, actual traffic patterns, to be able to do better forecasts for the allocation of then human resources to provide capacity when we need it, until we have an ability to produce capacity through higher levels of automation. So it's mainly about optimizing the use of air traffic controller resources that are scarce right now.
It's a huge challenge. I think it's fair to compare this to the energy sector,
Yeah.
where also you want to rely on renewable energies. But then again, you can never come to a point where you don't have power in your power socket, so you can't go lower than a certain minimum. And it's a little bit the same with the air traffic controllers, even if you can balance the demand and supply, let's say, perfectly, then you can never underscore a certain minimum. I think that might be the challenge here. Would you agree?
Totally. And to make the parallel, let's say, to the energy grid, you would like to have a maximum utilization of renewable energies, and you will maximize that. So my scarce resource is air traffic controllers.
Hmm.
And to utilize them at best and have I also need I need the nuclear equivalent connected to the grid, and that would become automation.
Makes sense. And automation or even higher levels of automation, including, let's say, AI. I always ask myself the question, how difficult is it to include those elements in air traffic management because of the high level of safety that you need? And those elements, they are not deterministic, but they are probabilistic. So it's always, statistical distribution, how they would behave. So how do you feel about this challenge, integrating AI in such safety critical systems?
If I answer, I would say the first thing is, let's not mix up AI and automation. Okay, you can have automation without AI if you just use deterministic logics, and I think that is something that has been basically, this is what happened in the cockpit. If you look at the aircraft system design, and we are of course going to push for higher levels of automation. The question then is, what is the range of use cases for AI in an environment that would be more highly automated? And the range of potential use cases then goes up. And I could see some, I would say, low risk applications of AI already having a number of positive benefits in a highly automated environment for everything that is about optimization, the strategic dimension of flying. Where I think it is going to become much more complicated is when we go closer to tactical, to separation implementation, type services. There, I believe that we may stick to completely deterministic systems and logic for the foreseeable future. And I would even argue probably for the right reasons.
Okay. So you make the distinction between, tactical or in situ decisions and operational support versus the strategic planning beforehand. And those two dimensions are also something that play a big role in the topic of contrail management, a topic that has been hugely discussed on this show.
Yeah.
How do you feel about this? Are you concerned about the non-CO2 effects of aviation?
I'm very concerned about the non-CO2 impact when we see that under certain circumstances, it can have such a more negative impact on climate. And I think we all should be concerned about it. Then when you look a little bit further, you realize that situation in which contrail formations are really a risk are in specific regions in Europe, concentrated around certain, let's say, times of the year. And then the issue becomes, okay, if we would have these, I would say, eco-sensitive areas, how do we manage them? And I think this is a very interesting challenge for innovation that should be relatively easily solved if we just focus on the right technological solutions. And we are working hard to do so, whilst also we are stimulating the scientific community to still reduce some of the uncertainties that are linked to potential trade-offs between CO2 and non-CO2 impacts in terms of the ultimate impact on climate. And that is one of our big priorities for the years to come.
Is this one of the examples that earlier you alluded to when you said, around consensus, one also always debates about what are the actual implications. So if you really have consensus around the non-CO2 effects of persistent warming contrails, then what are the implications and how fierce do we want to avoid those contrails? Do you see a lack of consensus about the implications in this topic as well?
I wouldn't say a lack of consensus, because to me, lack of consensus has a very strong meaning, which would mean basically we are stuck somewhere. We are not moving anymore. We are moving and we are not stuck on this topic. We are moving really hard. I would say more, you have a camp that speaks more out of fear. And that camp would sound something like, we have a war in Europe. Close to 20% of the airspace is basically not available because of that. What if we would on top have eco-sensitive areas that would make even more airspace unavailable at a time where we are struggling with the return of traffic in the post-COVID era with controller shortage? So this is kind of the fear space debate and angle. I would say love space is more, this is a really interesting challenge for our community, one we can probably live up to, one where, provided we have the right scientific evidence on, the total impact of flight and the climate impact in time of non-CO2, it shouldn't be too difficult to have solutions that would allow actors to reduce the total climate impact of flying. And that, you see already great examples in the flight planning domain where, you have companies that are developing methods for airlines that would like to avoid contrails today. And there have been trials with Southwest, for example, that have been very interesting. We are doing this also now in ATM and within SESAR, and looking at what can be done. And I mean, the solutions within REACH are not so complex to implement. It's then the operational feasibility and the operational impact of all of this that is just generating a lot of fear, because some see it as, okay, we will have a lot of airspace that is not available during certain times of the day, certain times of the year, certain airspaces, and that is going to be very difficult to manage.
You mentioned the interesting trials and stakeholders that are pushing this topic. And of course, there are also SESAR projects which are looking into the non-CO2 effects mitigation or even persistent contrails mitigation. Now, taking all of these things into consideration, at what scale would you say should we act in contrail management today?
I mean, I would argue that obviously we need to. This is a typical example for me where not a state alone or no company alone can fix it, and that we need to work together. So the offering in the SESAR context is to do that at a, I would say, continental scale in Europe, and we will be advocating our visions, our solutions, and the regulatory adaptations that are necessary also at a global scale. I think the ATM dimension is one of the dimensions of contrail management. I mean, if you then look at much deeper ramifications with potential implications on aircraft design, use of certain types of energy, with hydrogen, hybrid electric. I mean, we will have huge challenges in making sure that whatever aircraft we get in the future, and hopefully, the promise is that they will be quieter and have less potential to produce emissions, that we really make the best out of these aircraft. So it is de facto will have to be a global endeavor. But as Europe, our mission is to be at the forefront and part of the progressive forces in the world in tackling this program.
We need to wrap up this episode, I'm afraid. And in the tradition of the podcast, you also have the chance to pass on a question to our next guest, as you've answered the one from Chris Deseur already. And our next guest will be Jo Dardenne, the aviation director from Transport and Environment.
I think one of the questions that I would like to ask her is, what would it take for them to recognize the efforts we do as sufficiently credible to give confidence that we are on the right track to decarbonize a sector that has a lot of environmental pressure? Because we are naturally, I would say, everyone at SESAR are passionate about aviation and true believers in the cause of making Europe the most efficient and environmentally friendly sky to fly in the world. And I believe that it is not always easy to motivate actors when there is such a bad press about aviation and the efforts we do. So making sure that I would say the good initiatives, progressive forces are supported.
This is not only a great question, but it's also a perfect word to round off this episode with, stating all of the ambition that you have for a more sustainable future and sustainable aviation. I totally share that. And I totally appreciate you, Alain, being guest of the episode today. So thank you very much for that very good conversation.
Thank you, Marius. All the best.
Speak soon. Bye-bye.
Bye.